Okay, so today will probably be our last lecture with new content. It's on database connections. It's a pretty weird place to end the course, although it does connect databases, because in this last chapter we've been learning about databases. It does connect them back to our earlier content that we were covering, which was C#. So this is like joining C# and databases together, right? Like connecting to a database from C#. There are some other parts of this section about the different ways to store complex data for C#, for use in C#. It's not too difficult of a section, and we should get through it quite quickly, actually, but I don't know, we'll see. So I guess let's just start working through it. So as I said, this chapter does contain some stuff that is, I would say, probably not strictly related to databases. So one thing that it contains here is XML, so extensible markup language, which is like a text-based way to represent structured data. Now, you guys have seen XML before, actually. You have seen XML before. Does anyone remember in what section? I'll tell you that it was in chapter 4, and there was a particular thing in chapter 4 that used XML. Do either of you remember, maybe? I'll maybe give you some time to think about that. So chapter 4 was on these various kinds of web applications. And there was a particular thing on the web that used XML. Hey, that's it. Yeah, so Clark, web services. You know, actually, Yusuf, saying interfaces, that's not bad intuition, I suppose, because web services can sometimes, or web services are a type of API, like application programming interface. But we didn't learn about APIs specifically, but in a way, a web service is an interface to communicate with a server. So you know what, I'll give it to you. But yeah, specifically it was web services. They used something called Simple Object Access Protocol. Like when you were accessing a web service, you sent a little message, and that message had like an envelope and a head and a body. And that was XML. Okay. Now, XML, you don't really have to be taught it. So as I said, it's a text-based way to represent structured data, which is probably why it's in chapter 6, because chapter 6 is all about structured data, right? But yeah, this is a text-based way to represent structured data. And the cool thing about it is you don't need to be taught XML. You really don't have to be taught it. So look, I can show you this here. So this is actual XML. This is perfectly fine XML. And actually, if you guys just read through this line by line, just read through it line by line. I know it might look scary at the beginning there, but just keep going. And can one of you guys tell me, what do you think this XML is representing, this XML file here? What do you think that represents? And remember, you guys have never been taught XML, so maybe being a little bit apprehensive is fine. But if you just read through each of these lines here, what does this look like to you? What do you think this represents? Give you guys some time. Set of rules. Read carefully, hey? Every line. And just read the whole thing, even if you don't quite. And just see, like, rely on what you recognize. Rely on what you recognize. Where do you think this would be used? What data is this representing? Okay, I'll draw your attention maybe to line 4 of this, line 5. Tags. Yeah, there are tags there, but what data are they representing? Right, so one tag, for example, is company name. What does that mean? Company name. What data does this represent? Where might you see this used, this specific XML file? Where would you see that used? What data is it holding? Okay, I'll give this one away. Maybe. So this is representing companies and their stock price, right? So you can see we've got a list of companies. That's what this companies to slash companies is. We've got a company ID, TSLA. That's Tesla's stock ID. I don't know actually what they're even called. Doesn't matter. The company name is Tesla, and the stock price when I made these slides was $433. And then we have another company ID, NEO, company name NEO Inc., NEO Incorporated, and the stock price was $21. But yeah, so this is just a list of companies along with their stock price, right? Okay, so didn't get that one, but let's see another one. So this one on the right here. Having read this one on the left, what do you think this one on the right is representing, guys? Have another go. Again, you guys have never read XML before, so it's okay to be a little bit confused, but take a look at this one on the right. What do you think that represents? Where might you see this used? And images and its username. Exactly. So perhaps we would see this used on a website where you can upload images, right? So you can put your username, your like the description of your image, and then like there's a URL to your image. Yeah, you could see this on Google. In this case, you can see this URL here. So it's https i.red.it. Where do you think, what website do you think this is, Yusuf, looking at the URL? Exactly. There we go. So you see, you can. It's not difficult to read XML really. It's like fairly straightforward. You can see we've got two images here. The first one's ID is 1. The second one's ID is 2. We've got the username, description, and URL. So you can see it's structured data, but it's represented in text. Okay, so that's what XML is good for. And you can see how this relates maybe a little bit to databases because it's structured data, right? You can imagine representing this in a database as well. Cool. So there's some things we have to discuss about XML, but like, as I said, you don't really need to be taught it. It's very easy to read. XML, extensible markup language. The reason extensible is in the name. So you guys know what a markup language is. We've discussed other markup languages before, particularly HTML, hypertext markup language. The reason they're called markup languages, a markup language, is a language that's designed to be readable for both computers and humans. Okay, so it's like the middle ground. Computers can read it easily and humans can read it easily. Then it's called a markup language. This is called extensible markup language. Extensible, that means like able to be extended. The reason it's called that is because you can make up your own tags. You can just make whatever thing you want. Any tag you want, you can just make in XML. You can just make up a tag and it'll work. So that's why it's called extensible. Cool. The other thing we must know about XML is this first line here is called the XML declaration. It's just specifying the version name and just a bunch of information that the computer needs to know in order to be able to read it properly, okay? These are often called processing instructions, but all you need to know, you just need to know the names of these because it's kind of like you can hypothetically be asked a question like, where do we see the processing instructions of the XML documents? And then you must just know that it's the first line, okay? Is like the processing instructions or the XML declaration. Next, we call each of these like a XML elements. Each set of opening and closing tags, at least in your textbook, they refer to that as an XML element. They're not always called that, but sometimes, okay? And in your textbook, they are called that. So get used to referring to them as XML elements, which is fine. Cool. So the next thing I want to show you guys is just quickly, and it won't be difficult, it'll take long. I just want to show you guys how to load an XML document into C#. Okay, so if you didn't get the first two, we'll now see another XML document that you guys can give a try, give a shot at reading. So let me just open that. Ooh, okay, let me not open this in, wow, Internet Explorer. I didn't even know I still had Internet Explorer installed on my computer, to be honest. Okay, but actually, you know what? It's fine to read it this way, but I just want to show you actually, because this is just a text document, basically. I can just open this with Notepad. So I'm just going to open it in Notepad because this is how I made it. Okay, so here it is. Here's our XML document. And what do you think this one's representing, guys? This one's also, I think it's pretty easy. What do you think this one's representing? Anyone have any ideas? A letter. Can we be a little bit more specific than that? A letter, sure. What kind though? I mean, like, let's look at the whole file, like look more holistically, perhaps. What is this representing? In a way, it is a letter. It's more like a modern kind of letter. Exactly. Okay, so it's emails. Okay, because you can see. So it says emails, email, the person who the email is going to, the person who it's from, subject, body, email. Okay, fair enough. I don't have an email address here specifically. So, I mean, obviously this is just as an example, but you can see it's got like email there. So it's telling you that this is now, this here is one email, and you can see the person it's to, the person it's from, the subject, the body. Okay, this here is another email. Okay, the person it's to, the person it's from, the subject, and the body. Okay, so this is an XML document attempting to represent emails without email addresses. Not really sure how you would do that, but hypothetically, that's what this is. Okay, cool. So what we're going to do is we're going to read that email XML thing. We're going to read that XML document into our C# application, and that'll be our first introduction into using XML or using structured data in general inside C#. So I'm going to make a C# console application over here in Visual Studio 2019. Let me just make sure everything's being saved to the correct folder. So we're saving to workspace. And we'll call this MTA Saturday 06, perhaps. Seems like a good name. And oh wait, I'll call this. Okay, there we go. And this will just be XML. Oh, okay, no, we'll use this for everyone. So I'll just say console app. Okay, 1. Cool. So I'm going to create that. Okay, it'll take a little while to create, but that'll work. Right, and while that's creating, so inside C#, there's a namespace called system.xml, system.xml, okay, system.xml. And as the name of that namespace implies, it holds a bunch of classes and interfaces that are used to read and write XML documents, to read from and write to XML documents. So what I'm going to show you is we're going to go into system.xml and we're going to use an XML reader to read this XML document that we have here. And you guys will see it's not too difficult. It's exactly like the old C# objects we were creating. So here we are in our console-based application. I need to tell it that we are using system.xml, okay? Using system.xml, like so. So I'm just telling it that the classes inside that namespace, go and fetch them and bring them here. Okay, cool. So we've got access to all of that stuff, and we're just going to use what's called an XML reader. And this is just like an object, just like any other object. And we are going to, we just need to create an XML reader. So we're going to say XML reader. Okay, XML reader. Okay, so that's going to be our XML reader object. Okay, and inside that XML reader object, we just want to read a particular XML document. So we're going to say XML reader dot create. So the reason I'm doing it this way, I suppose I should mention this. It's quite good. It's good revision, I think. Usually when creating a new object, you guys are used to, like, you can imagine if we had a rectangle class here or a person class, we would say like rectangle rect equals new rectangle. Okay, like that. So that's how we would do it usually. That's how we would usually create a new object. But here we can't say new XML reader like this. This won't work. Okay. And you can see, like, if I mouse over it, it says represents a reader that provides, and guys, remember this language here. So represents a reader that provides fast, non-cached, and this one is important. Please remember this. Forward only. Okay, forward only. That's a key word that you're going to see is true in all of the readers that we are going to be using. They're forward only, and I'll explain what that means in a bit. But then you can see that below here, over here, you see it says, cannot create an instance of the abstract class or interface XML reader. So XML reader is abstract. It's either an interface or it's abstract, but in both cases, I mean, interface just means public abstract, basically. So this is an abstract. XML reader is an abstract class, which means it can, you can't directly create it, but it does have a static method called create that allows you to create an XML reader object, okay? And you just have to give create the name of the XML document that you want to read, okay? So our XML documents is over here. See, here it is, emails.xml. So the name of this document is emails.xml. So I'm going to say, I want an XML reader for emails.xml. Okay, so I'm just reading emails.xml. Okay, and once you get that, it's pretty easy to read this, right? XML reader, so that's our reader object, is just going to hold a reader for emails.xml. That's all that's saying. That's all this line is saying. Looks a little weird maybe if you're not used to that kind of notation, but it's pretty okay. Now, immediately, I'm just going to actually build this, okay, just so that I can get the URL where this is built to. So I just right-clicked on the solution and clicked build, and you can see it's saved. It told me where it's saved to: users, desktop, workspace, console app 1, MTA Saturday 06, bin debug MTA Saturday 06.exe. So I can go there quickly. So I'm going to take this emails.xml document. I'm going to copy it, and we're going to go into MTA Saturday 06. Wherever that is. Oh no, is it saved here? Oh yeah, okay, cool, that's fine. MTA Saturday 06, bin, debug, and you can see there is our thing, and I'm just going to put the emails.xml document here so that our console app is able to find it when we run it, okay? So when we run it, it'll be able to find emails.xml. That's all I'm doing there. Cool, and now we can actually work with this. So we'll be able to read this into our file, and so it's forward only, okay? It's forward only. So what I'm gonna do, I'm just gonna show you this. So I'm gonna say, and I'll do it this way first. So I'll say, we are gonna use a loop to loop over each line of the XML documents. And we do that by saying while reader dot read, okay? Like that, while reader dot read, while reader dot read. Okay, and for now, I'm just going to print out. I'll just print out console.writeLine reader dot. Okay, now this is what's nice about using Visual Studio is it'll give you all of the different things that you could print out. And we're for now just going to print out this. We're going to print out reader.name. Okay, and you can see this says gets the qualified name of the current node. So let's just print that out and let's see what this object is giving us. Okay. So we're just reading through the whole document while reader.read. So while the reader is able to read a new line, we're going to read that new line, console.writeLine reader.name. So let's see what that does. I'm just going to build this again, and we'll see when we run it. So in order to run it, I'm going to have to open up a command prompt. So I'm just going to type CMD there, command prompt. Okay, here we are in command prompt. So there's a special command called chdir that'll allow me to change to this directory. So I'm going to go to this directory where MTA Saturday 06.exe is. So I'm going to say chdir, and we're going to jump there. Okay, there we go. I'm in that directory, and we're going to run MTA Saturday 06.exe. And you can see this is what it prints out. It prints out that. Okay, I'm going to open this on the side here and open Notepad on the other side. And you guys tell me what do you think's going on here? So okay, it cut off some of the things that it read. Okay, so does that look right to you guys? What's going on here? So I'll ask you a couple of questions about this. So you see it says while XML. Okay, that's this first line here, right? While XML. I mean, sorry, it says XML, sorry. And then it says emails. Okay, that's that line here. Then it says email. Okay, cool. It says email. That's this line over here. And then it says to. Okay, that's this line over here. And then it says to again. But but why isn't it from? So what do you guys think about that? Why is two twice there? Why is there two twos? And why, and you see in the next bit, there's also two froms. That's a little bit weird. Why is there two froms here? Why is there two subjects? Why is there two bodies? What's going on with that, guys? Does anyone have any suggestions? Why is that happening? Anyone have a suggestion? Take a look at this document. So we got XML, that's cool. Got XMLs, that's the first line. Two emails. Perhaps, Croc, but you see it goes again down here. There's two twos over here, and there's two froms, and there's two subjects, and there's two bodies. But then there's only one email here and one email's here. Okay. So think about how the computer reads this. It goes, okay, this is the first node over here, XML. Cool, it reads that. That's node 1, and it prints out XML. Then it goes, okay, this node here, this is emails. This is email. Okay. Ooh, I see someone else joined. Welcome, Taffy. Then it goes, okay, here's email. Email, okay. Then it goes, okay, here is two. Okay, two. Where does it get the second two from, guys? Why is that second two there? Okay, I'll explain it, I suppose. So what you can see is that every single tag has a closing tag, right? So you can see we've got tag, tag, okay? Tag, tag. So it's going two, that's this two. Then it goes, there's this blank space here. What's this blank space? This is what the tag would be holding, the tag's value. And then it goes two again. That's this two, okay? Then it goes from, that's this one, from. Then it goes from again, that's this from. Subject, subject, okay? The closing tag, the opening tag, body, body, the opening tag, the closing tag. And then we've got email. This email is this one here. This is the closing tag of that email over there. And then we have another email. That's the opening tag over here. And then we've got two, from, subject, subject, body, body, and then email again. That's the closing tag of email here. And then we've got emails. That is this closing tag of this first tag here. You see that? So that's why there's two of everything, okay? Because there's that closing and opening tag. All right, cool. So that's reader.name. Let's try printing out something else. Let's try printing out, because there's also reader.value. Let's print out reader.value. Okay, so I'm gonna just build that again, build. And now we're just gonna print it out again. So all I did was I changed reader.name to reader.value. Okay, and now we got this. All right, so now we get Ali, Josh, plans, want to get some breakfast tomorrow, or Devon, job offer, you got the job, when are you coming back to South Africa? Okay, so now you can notice that it's printing out the thing inside the tags. But what's with all these spaces here? What's with all these spaces? Why is there so many spaces here? That's a bit weird. And guys, the reason for that is because every single XML node, this XML one, it has the name and the node, okay? Emails, the name and the node, okay? Email, the name and the name and the value, okay? Two, the name and the value. And then we're at this one, the Ali, which is just the name, okay? The name and the value. So this blank line is standing in for what would be the name of this middle node over here, okay? So it's a little weird, but you can see the logic here. It's clearly being read how a computer would read this. Okay, but let's get some more structure in here. So we now know what value is, we know what reader is, and cool. So there's also a cool value, a cool function, and it's maybe a little strange, but you can see that some of these are starting tags and some of them are ending tags. So I'm going to go back over here where we're printing out reader.name. You can see, so email and email, okay? So we've got this, actually we'll use an example that is closer. So we've got 2 and 2. Now these look exactly the same, right? 2, 2. They're the same, right? They're the same tag in a way. But you can see that one of them has the slash, which means it's the closing tag, and the other has no slash. It's the beginning tag. So you're able to ask this question. You can say if reader.isStartElements, okay, like that, right? And all this tells you is the bit that I'm currently looking at, is the node that I'm currently looking at the start of the elements, okay? Basically, if I'm looking at a to tag, is it the one that has no slash or is it the one that has a slash? If I'm looking at the from element, is it the one that has no slash or the one that has the slash, okay? If it's the one with no slash, then this returns true, otherwise it returns false. So this will tell us is, what this will tell us is, are we currently looking at the start of an element? Is this the start of a new element, okay? And now this might work a little bit better because now we can say that, okay, we want to do like a if, or we can even just do like reader.read and then just console.writeLine, console.writeLine reader.value, okay? This still won't be perfect, but it should improve our program a little bit, okay? So you can see that previously we had all these spaces. Now we should have slightly less spaces, okay? You see. So now we've still got these spaces at the beginning here because there's a lot of start elements there, okay? There's some start elements here as well for email. But you can see now between the messages, we don't have any spaces, okay? Because we are now checking if it's a start element, and only if it's a start element do we print out its value, okay? So that eliminated some of the spaces. But now we've got the problem that we're still treating all of them as the same. We're treating all of the nodes the same, whether it's an email or emails or to or from or subject, we're treating all of these nodes the same. So what we're gonna do just to show you, we're going to check for specific kinds of tags, okay? We're gonna check for specific kinds of tags. So do you guys know what structure we would use? We've used an if statement here, but you can see there's a lot of different names here. There'll be a lot of branches. This is like a multi-branching decision, is how we might say it, okay? We've got emails, we've got email, we've got to, and if it's to, we want to do something different. If it's from, we want to do something different. If it's subject, we want to do something different. If it's body, we want to do something different. You see, there's so many cases here. There's so many different options. How would we make this decision, guys? What structure am I going to use? I'm going to type a specific word here in order to help me make this decision. What structure am I going to use in order to make this complex decision where there are so many options here? Okay. To, something must happen if it's to, something must happen if it's from, something must happen if it's subject, something must happen if it's body. What structure can I use to make this decision? Welcome, Chris. Good to have you as well. Anyone know what structure do we use to make these complex decisions? We've used an if statement here, but you can imagine if I was to use an if statement here, it would be like, no problem, Chris, I understand it, guys. It's a Saturday. I'm also often late on Saturdays. Okay, so we can say like reader.name equals email, right? We would do like a else if reader.name equals. Is there a faster way to do these, guys? You see how many cases I would have to type out here? It would be a bother, right? There's so many cases that we would have to go through here. We would need another else if statement for from, another else if statement for body, another else if statement for subject. Is there not a faster way that I can make these kinds of multi-way branching decisions? What structure do we use? What decision structure do we use? Does no one remember? This is from way back in chapter 1. Okay, I'll give you a hint, and this is there we go, exactly, yeah, switch statements. Cool, so we'll use a switch statement. Okay, guys, so we're gonna switch over reader.name. Okay, so the name of the node that we are looking at. Is it to, is it from, is it body, is it subject, okay? For now, just for the sake of example, we're just gonna print out the subject and the body of each of the emails. So we're gonna say switch case, if it is the body, okay? Oh, actually, let's do the case for subject first, since the subject would usually come first, so that just makes more sense, okay? So if it's the case where it is the subject, Otherwise, it's the case where it's the body. And these are the two cases that we're going to process. If the tag is a start element and it's the subject, then we just want to read the next little bit to get the value. Okay, so you can imagine, let me just show you what it will be that we're doing here. So we said if it's the start element, okay, so all of these are start elements. Emails here, it has no slash, it's the start elements. Email here, this has no slash, it's the start elements. To, it has no slash, it's a start element. From has no slash, it's a start element. Subject has, etc. Okay, if it doesn't have a slash, it's the start element. So we're going, okay, this is a start element. If it is subject, then what we want to do is we want to read just one more bit so that we can get the value, and we want to print out the value. So that's what we're going to do. We're going to go reader.read to read the next little bit, and then we're going to go console.writeLine, and tell you what, we'll even format it nicely. We'll say subject plus reader.value. Okay, so it'll print out nicely even. And we'll do the same for the body. So we're just going to say when it's the body, we're going to just do the exact same thing. We'll read one more time, and we'll print out, the only thing we'll change is that it'll be body. Okay, there we go. So let me just build this, build. Okay, there we go. And we'll go and run this. And you can see we get subject, plans, let me see. So subject, plans, body, want to go for some breakfast, subject, job offer, body, you got the job, when are you coming back to South Africa? Okay, so you see, there you go. That's how you process an XML document. I think it's not too bad, like once you follow the logic. If you struggled a bit, then please do just rewatch this part of the YouTube video. Also, if you were late, please do rewatch it so that you can get the beginning intro part of XML. But yeah, so that's it for XML, and we can jump into the next bit now. Okay, so that's one way to represent structured data that C# is able to read and work with. But there are others. Okay, there are others. So for example, there could be a database, hypothetically, an actual database that like the ones we've been working with up till now, and we might want to use such a database inside C#. So I've set up a database on my home computer here. It's called the AdventureWorks database. It's a very popular educational database that people work with. Okay, here it is. You can see I've connected to it on the right here. There's userpc.adventureworks.dbo. DBO is like a database file, database object. That's what that means, DBO, database object. Okay, cool. And you can see here are all the tables inside our database. You can see there are a lot of them. There is an error log, departments, employees, employee departments, employee pay history, job candidates, shifts, address, business entities, illustrations, documents, culture, etc., etc., etc. Okay, there are a lot of, you can see there are a lot of databases here. One particularly interesting database that we'll probably be working with today is the person table. Sorry, the one interesting table is the person table. Here it is, the person table. That's it. Okay, and you can see the person table has a whole lot of columns in it. It has a person type, a name style, title, first name, middle name, last name, suffix, email, promotion, so like their email for promotional purposes, additional content info, some demographic data, etc. Okay, cool. So we're going to query this table here. So and we're going to do it in C#, but you guys will recognize the query. Okay, so I'm going to right click on table here inside Visual Studio and hit new query. Okay, new query. And here we are. We've got a SQL query set up here. Sorry, Visual Studio is very slow, especially when I have Zoom open. Okay, cool. So here we are. And I'm just going to write a simple SQL query for now. So I'm going to say select star from. Okay. Now, usually the person table we are working with, it would be called person, right? So we would just say select star from person, and that would go and fetch everything from the person table. Now, when you're working with the database this big, things are a little bit different, okay? It's not a substantial difference, but because there's a lot of databases in the world, right? Like this isn't just DB Fiddle where we've got the one database that we're working with. And there could even be a lot of tables with the same name. There could even be a lot of tables that are called person, okay? So we have to be a little bit more specific. We have to tell C# what we are querying, or SQL what we're querying. You need to be like, we're querying the AdventureWorks database. The AdventureWorks database, the person object, and the person table, okay? Now, what do you might be thinking like, okay, if I just said AdventureWorks.person, that might make sense, right? The database is AdventureWorks, the table is person. Why do I have the second person here? You might be wondering. Okay, I'm just going to show you where I saw that just for the sake of interest. You probably would be tested on this though. You can see that next to the person table, it has in brackets person. And like here, it has password person, email address person, person phone person. And eventually we get to like bill of materials production in brackets. Okay, so the thing in brackets is the object that it's a part of. So like, let's say address here, address person. You can imagine there could be address company, right? Like another table called address that is holding the addresses of companies, right? Then I could say like, so I could say person address, that'll give me the addresses of people, but I could also say company address, and that would give me the address of companies, okay? So that's why there's this object here. That's what the second thing is for. But we're going for person, person. That's the table we're looking for. Okay, so a slightly more complex than the queries you guys have seen before, but I'm just going to run that now, okay? And we'll jump over to the results. Okay, and here's our table. You can see this looks a lot like what we would get from DB Fiddle. It's just printed out our table here. Okay, I'm going to scroll all the way down to the bottom. You can see that our table over here has 19,972 people in it. 19,972. This is a big table, guys. There's a lot of people here. You can see I'll scroll through it. It's a big, big table. This is a lot of data that we're working with now. Okay. But you can see the query was the same. It's not really that much more complicated. I mean, obviously we had to tell it what database to use, but other than that, this is exactly like the queries you've seen before. Select, star from, and then the table that we want to select from. Okay, cool. So there we go. We've got a simple query. Let's switch it up a little bit. Let's select specific, let's do a more specific query just to show you guys that it still works. So I could also say like where first name equals, and we can give them a first name to use. Let's think, which one of us has a common, I think we probably have the best shot of finding like a Clark or a Christopher, but we can, let's just try some others. Let's see, is there a Yusuf in this database? I think it's an American thing. Okay, so there's no Yusufs. Is there a Clark with the E? Maybe a Clark without the E? There is no Clarks without the E. Is there a Christopher? Let's see, do we get a win on one of these? Ah, okay, there are 21 Christophers in the table. Okay, so we've got some Christophers. Okay, and you can see there's 21 Christophers, so the where statement worked. Okay, the where statement worked. It found everyone whose first name was Christopher, and you can see the first name row here, it's all Christopher. Okay, so this is a standard SQL query. We've got the SQL queries down. Okay, so that's that. I'm going to leave it at selecting the entire table, just because that's, you know, lots of data. It's cool. Okay, great. So what if I want to do this? So we can see how to do this with SQL, but what if I want to work with this inside our C# document here? What do I do then? How do I work with that data inside C#? And the answer, it's actually not too bad, guys. It's actually not too bad to do this. We can pull any query we like into C#, and we do it with this little bit of code here. It's just 6 lines, about 6 lines. And actually you could do it in fewer than 6. This is just to make it clearer, okay? Let me just hide this from you guys quickly. When we were discussing about websites, when we were talking about websites, there were 2 sides of a connection, if you guys remember. There was the thing that was connecting to something and the thing that was being connected to. What did we call these 2 things? There was the computer that was connecting and the computer that was being connected to. What did we call these 2 sides of the relationship, guys? Of that connection relationship? What were they called? I know I might be being a little bit vague, but hopefully one of you can get what I'm working towards here, because it's good to think about here why things are called what they are called. So if we were making a request to a website, what did we call ourselves? We are the computer connecting to a website. What are we? We're exactly, Clark. Yes. So there's this client-server relationship. Okay. So the database at VentureWorks, you can see on the side here, Server Explorer, Server Explorer. At VentureWorks, the database that we are connecting to is a server. It happens to be the name of the server that it's on is user PC. Okay, that's my computer. It's this computer. Its name is user PC. But you can imagine that could be any server in the world, right? That's the server we're connecting to. In that relationship, this C# document is called the client. Okay, the C# document that's connecting to the server, the C# code that's connecting to the server is the client. Okay, we're the client. Okay, so when we want to connect to a database like this, the namespace that we go and fetch is called SQL client, system.data.sql client. Okay, so I'm just going to import that here using system.data.sql client. Okay, that's just going to give us everything that is required for us to be an SQL client. Okay, all the classes and interfaces that are required. Okay, and now you know why it's called that, right? You know why this is called SQL client, because we're the clients. Okay, cool. So that's the first thing. Okay, the next thing we need to do is set up the connection. We need to connect to the server. So that's these first two lines here. Okay, so we've got string connection string. Okay, now this is just a string. You know how to create a string. So I'm going to say string connection string. Okay, equals. It's literally just a string. There's nothing more complicated than that. It's called a connection string. And where do I get this connection string from? It'll be over here somewhere. Let me just try to find it quick. It sometimes can be a little bit of a mission. Let me check out the properties of this. There we go. There its connection string is. Okay. Okay, I'm going to copy paste that over here. Okay, there we go. That's our connection string. What is this? So it says data source equals user PC. So that's the name of our server. That's the name of the server. Catalog equals AdventureWorks. So that is the name of the database that we are connecting to. Integrated security equals true. So this is just saying that the security, turn all of the security on. You know, the connection must be encrypted. If it requires a password, then let me put that in. You know, all of that kind of stuff. Okay, so this is just the details of how we connect to the database. The details of how we connect to the database. Cool. So that's the first bit. The next thing is we open up the connection, or we initialize the connection. We get everything ready for the connection. And we do that using a class called SQL connection. SQL connection, okay? SQL connection equals new, I'm going to call my object connection. So SQL connection equals new SQL connection. And we just give it the connection string that we are interested in. Okay, the connection string. So this object, this string over here that gives all the details of the database and the server that we are connecting to, we just give the SQL connection that connection string so that it knows what it's connecting to. Okay, so that's the first step. That's setting up. Our connection is now ready. It's not open yet. It's just ready. Okay, it's prepared. All right, the next thing we need to do is set up the command that we are going to run, right? Because we're going to open up the connection. We're going to go to the server. We're going to run an SQL query, right? This SQL query over here, select star from adventureworks.person.person. We're going to run that SQL query, and then we're going to want to get the response back later, okay? But the first thing is to set up that command, okay? So we set up that command as an SQL command. So SQL command, I'll call it command, SQL command equals connection, okay? So our connection here, so we are linking the command to the connection. So SQL command equals connection.create command, okay? So this links the command to the connection. In fact, you can see if we go over here, you can see it says creates and returns a SQL command object associated with the SQL connection, okay? So our connection over here, we are linking this command to that connection, okay? And what command are we running? I can go and copy this exact SQL statement over here. I just must have a sip of water quickly. Okay. The exact SQL query over there, select star from adventureworks.person.person. That exact command is what we can give to the .create command. Ooh, wait, no, we link. Okay, I wasn't even following my own slides here. Sorry, we set the command text at the next bit. Okay, hold on. So that creates the command. We then have to tell it what command we want to run. So we say command dot command text, okay, dot command text like that, and then we set the command that we are going to run. But you can see it is the exact SQL query, right, as a string. Select, need a space there, select star from adventureworks.person.person. It's the exact query that we want to run, okay, the exact query. Cool. We can leave out the semicolon because it's it'll automatically know that this is the end of the command. Okay, cool. So that's our command. Okay, that's our command. And now it's just about actually going and running that command. Okay, we just need to go and run that command. Connection.open. Okay, connection.open. That opens the connection. If you want like a more detailed explanation, you can just mouse over it. Opens a database connection with the property settings specified by the SQL connection.connection string. So opens the connection with the connection string. Okay, connection.open. So now the connection is open. It's ready to run the command. And now we just run the command and we need to save it somewhere so that we can read it. Where do we save it? We save it in what's called an SQL data reader. Now you guys remember, I drew your attention to something when we were reading about the XML reader. It said the XML reader provides a fast, non-cached, and then the important word was forward only, right? Because we said read, read, read. We went down through the file. There was no going back. Okay, there was no going back. We read the first line, then the next line, then the next line, then the next line. It's forward only. And it's the same with this SQL data reader. Provides a way of reading a forward only stream. Forward only stream. Okay, so you see every single time we're using the reader object, it always says forward only. Okay, so we're going to explore what that means more. What is forward only? Why is it forward only? But I've already told you basically, it only goes one way, right? You read line by line by line by line. There's no going back. There's no further processing. You just read, 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 read. Okay. So SQL data reader equals, and then we just want to run the query. So we say command. That's our command object over here that has the query saved in it and the connection. We're going to say command dot execute, and we want to execute reader. Okay, command dot execute reader, like so, and that executes the command. And when we come back, we'll see how to actually process this reader. How do we actually read it? Okay, but yeah, cool. For now, though, we'll leave that there. We're going to take a little break. Let's see, are we making good time? There's quite a lot of stuff that we still have to discuss, I think. But no, I think we're doing good because we still have quite a lot of time after this. Let's do a 10-minute break. I'll be nice. Hopefully we can still finish today. So we'll come back at 10:05. Okay, guys, if you have any questions about anything during the break, feel free to ask. And I'll give you details about the revision sessions and when exams will be written at the end of the lecture, okay? But yeah, cool. So otherwise, I'll see you guys in 10 minutes or so, okay? Cool. I'm gonna go get another glass of water quick. Be back now. Cool, I'm back. Let's see, what do we still have to get through? So finish processing. Yeah, Chris, you only missed XML stuff really. And yeah, it's not too bad. But yeah, I'll upload the lecture immediately afterwards as usual. So you can always catch up. Okay, I think let's get started again. Yeah, I guess the next bit is to just read from the reader. Right. Now that is slightly more. It's maybe a little bit difficult from a standard reader to read the table, because you must think that it's attempting to represent a database in terms of arrays and stuff like that, which can be quite a challenge. So I'll show you in what way now. It's not difficult to understand really, but yeah, we'll just try it out. Okay, so yeah, let's do that. So I'm just going to say while reader.read. So you can see this is exactly the same as when we were reading from the XML document. So this is just going to read line by line by line by line. And in this case, we're talking about a database. So line by line, we mean row by row by row by row by row. Okay, that's what reader.read is going to do. It's going to read row by row by row by row. Okay. Now it is a little bit technical. So here, or really it's not that difficult. I'm overhyping it. Let me just show you. So we'll say console.writeLine, all right, something like that. And what we're going to do is just, yeah, so we're going to print out, let's do two things. We're going to print out the like the name. Okay, hold on. How I somewhat forget. We'll print out the first name and the surname. I'm going to use this fancy way of formatting strings in C#. It's not too bad though. So like whatever is the first thing you give it here, like if I gave it hello over here, then it would replace this 0 with hello. And then if I give it like world over here, then the second thing will be replaced by world, okay? Because it's like the first thing and then the second thing separated by commas, okay? Inside console.writeLine. It's just a silly way of formatting a string. Don't worry about it. You won't be tested on it, okay? But anyway, so what are we going to print out? In fact, we can actually just use, no, let's stick to this way. Okay, so we want to print out, let's say, the first name and the last name of every single person in the table, okay? So we're running select star from AdventureWorks, person.person.person. Okay, that's our query. And that's reading into the reader. And I just want to get the first name and the last name of our query. Okay, so the one way of doing this is to go like select star from first name, comma, last name, or whatever. Like you could edit the query and do some fancy stuff there. But we want to do it here. So I want to tell you, if we get this whole row over here, we get this whole row in a response. Imagine it's saved in something kind of like an array. Okay, this whole row, and then this whole row, and then this whole row. If I gave you this whole row in, let's say, an array, what index would you access that array in order to get first name? Can anyone tell me that? If I gave you this whole row, starting from 1, EM, 0, null, Ken, James, etc. Okay, that whole row was given to you in an array. Which index in the array would you access for first name? Can anyone answer that? This is why I was saying it gets a little bit technical, because it's a little bit weird to think about a database in this way. Okay, but if you were given this all in an array, you guys know that in order to access an array, we would access like place in position 3, for example, or position 4, position 5, numbers in position 2, you know, things like that, like this. This is basically what I'm asking you, like, you know, when you access arrays like this, and this is the index. Okay. All right. So Clark suggests 4. Let's check that out. So you're saying like 1, 2, 3, 4, Clark. Is that how arrays work though in C#? Okay, guys. So it goes like this. So remember, and this is an important thing for you guys to remember, we always start counting at, 1, 2, 3, 4. We always start counting at 0. Okay, so 0, 1, 2, 3. Oh, wait, why was I counting so incorrectly? 1, 2, 3, 4, 5. Of course. Okay, yeah, 0, 1, 2, 3, 4. Sorry, Clark. Of course, that is correct. You are correct. Okay, 0, 1, 2, 3, 4. And last name, guys, where would, in order to access last name, how would I do it? Following the same rule that Clark just showed us. I'm sorry that I was struggling to count for some reason. Yo, why was that happening? Oh, I was only counting to title. That was silly of me. Okay, so yeah, we must say 0, 1, 2, exactly. So it'll be 6. Yusuf says 6, and that's correct. So you see, this is like if we given this in an array, this would be position 4 because it goes 0, 1, 2, 3, 4. And last name would be position 6 in this array, right? Because it goes 0, 1, 2, 3, 4, 5, 6. Okay. So how we do this is we'll say reader dot get value in position 4. That's going to give us the first name. And reader dot get value in position 5. That's going to give us the 6. Sorry, what am I doing? 6. Okay, that's going to give us the last name. Okay, if we said 5, that would give us the middle name, right? That would give us this, which is not what we were looking for. Okay, cool. Anyway, okay, that I overcomplicated that, but anyway, we've got it now. So hopefully that just runs. Assuming I got the format for the thing correct. Let's see. Okay, it's printing out 0s and 1s. What is going on here? Oh, okay, hold on. I think maybe I've messed up the formatting a little bit on this query here, on this command. Is that not how you do this thing? Okay, you know what? We're gonna do it the simple way, because when we get fancy like this, things break. Okay, so I'll say plus Okay, something like that. Let's try that instead and see if that gives us what we're looking for. Okay, because that's printing out zeros and ones, I think, because there were zeros and ones inside the the beauties of programming. Okay, there we go. We've got it. Okay, so you see it's printing out the first and last name of all 19,972 people in our database. Okay, so it's a lot of names. It's a lot of names. Okay, cool. So that's that. Okay, so that's how we read a query. That's how we read a query's response. But the thing is, there's a couple of other ways to run queries, particularly just two that we need to understand. So if we run it with execute reader, then that gives back the query in this reader object. But there's two other ways that we can run SQL queries in this kind of way. So we can use execute reader over there to run our query. We can use execute scalar, or we can execute non-query. Okay, those are the three ways. So we've seen execute reader now. That executes the command and gives us back a reader with the entire response. Okay, but there's also execute scalar. Okay, so let's just check out execute scalar. This returns just the first cell faster than a normal query, and it's good for counting. Okay, so the important thing about execute scalar is this returns just the first cell, not the first row, not the first column, the first cell. So what do we mean by that? In this query here, so all of these rows, all of these columns, right? This query here, if you ran it with execute scalar, it would return just this, just that first cell, just that one. Okay, that's all it would return. All right, which is pretty weird, right? But let's check it out. So we would say something like this. Okay. So we would say, let's say we're running that same query, but we say command.execute scalar. Okay, you see there it is, execute scalar. Okay, executes the query and returns the first column of the first row in the result set. The first column of the first row, so that's like the first cell. The first column of the first row, it's this one. Okay, that's all it's gonna return now. So execute scalar, that's what I'm gonna run. And you might be looking at this going like, why would you ever just want to return the first cell of your query? That seems very weird, but you guys will see now why it makes sense. I'm gonna say var here, because the problem with doing this is you don't know what type the first cell of the first row is, right? You don't know what type it is. So I'm just gonna store it in var. That just means like, I don't know the type. You must just figure out the type for me, okay? And then we're just gonna say console.writeLine reader. Okay, something like that. All right, and hopefully it'll figure out what's going on. Okay, cool. So I'm gonna go ahead and build this and just run it. Okay, and you see it just prints out one. Just prints it out one. Why did it do that? Because it returned the first query. It returned just that. It just returned one. Okay, and I can show you that that's what it's doing. I'll say, let's go back to our previous query where we were searching for all of the Chris's. So select star from AdventureWorks person.person where first name equals Christopher, and we just run that. Okay. Oh, sorry, I ran the program instead of running the query. That was wrong of me. Okay, let me just close that. Okay, let me run the query now. And you can see it fetched the 21 Christophers again. Okay, and you can see the first ID is 16,090. Okay, so let's replace our query with this query over here. So I'm just going to paste it there. Okay, so now we're getting only the Christophers. Okay, and I'm just going to build that. And let's see what this returns this time. So I'll run it again. And you see it just returned 16,090. Why? Because all it did was return the first cell, that first cell, top left, okay? 16,090. Now, what is this good for? What is this good for? And the thing is, this is good for one thing in particular. One thing in particular is the reason why why do I keep clicking that button? Okay, let me just run that again, cool. So this is good for one thing in particular, and it's when you are counting. So I'm just going to show you this new command. If you take this asterisk, you see the asterisk there, and you just wrap it in this word counts, like that. You see I'm saying select count asterisk from adventureworks.person.person. Let's run that and see what this returns. You see it returns one cell, 19,972. Now, do any of you remember, what is that number? What does that number represent? Why did it return that? What did this do? What did that count thing do? What did that word count do here? Anyone want to tell me? I'll give you some time. Exactly. That's the total number of rows that we had. So all count did was, instead of returning the asterisks, like instead of returning everything, it counted the number of rows in the response instead of returning them. And then it just returned a single cell. And now you can see, if we were running this query, you can see where execute scalar would actually be really cool, right? Because if we just ran that query instead, now it's just gonna return the first cell, the first row, the first cell, which is the whole query, right? Now execute scalar makes a whole lot of sense, right? Because now if I build this and I go ahead and run this, you can see that we just get our 19,972. Okay, 19,972, which is cool, right? That's useful now. You can see why that might be useful. Why do we use execute scalar instead of execute reader? Because you can imagine I could just read this into a normal reader and just click reader.read and just print it out. So why don't I do that instead of this? The thing is, because the computer knows that it's only fetching a single cell, this query is faster, okay? Because it knows the exact amount of memory that it'll need to store this and to run this query, because it knows it's only interested in the first cell. Right? It's very little. It's very little what it's interested in. And so it's faster to run this. And so when you want these queries like count that need to be run very quickly, you can imagine where this would be very useful. Okay, execute scalar is very useful because it's much faster. There's no for loop or while loop to read through the response. You don't have to create a whole new object. You just store this one little thing. It's a very useful thing. Okay. So that's where we might use execute scalar. And now there's one more, execute non-query. Execute non-query. So I can show you an interesting way that this might work. So we can say like the other queries that we learned about would still work, right? Like you could still run delete. Delete would still work here. Obviously, I'm not going to run delete because this is an actual server. So if I run delete, like if I ran delete from adventureworks.person, you can imagine it'll delete the whole table, and I couldn't just repopulate that table instantly. I'd have to recreate part of the server and go and read the table again. So I'm not going to run delete, but what we can do safely is run update. So you guys remember if we say like update, I'm forgetting how this command works actually, but if we run like update adventureworks.person.person, and then say like set first name equals, okay, let's change all of the Christophers, because there's a lot of Christophers in the table, 21 of them. Let's change all of the Christophers to Chris. So we'll say set first name equals Chris, where first name equals Christopher. Okay. Like that, all right? So we can see what this query should do, and I'm just gonna run that. And you can see this didn't return any table, right? It didn't return a response. It just returned 21 rows affected, 21 rows affected. Why were 21 rows affected? Because if you guys remember, there were 21 rows that had the first name Christopher, right? And all of those rows had their first name changed to Chris. So 21 of the rows were affected, right? Now you can imagine if I ran this again, if I run this again now, guys, how many rows will be affected? Just to make sure you guys are getting this. How many rows will be affected if I ran this query again? Or this non-query, as we might call it, non-query. Would there be one? Yusuf, one? Who would change? What row would be affected? Because now you guys agree, when I say first name equals Christopher, maybe. So if I say now where first name equals Christopher, will any row meet this condition? Will any row meet this condition over here? Because haven't all of the Christophers been changed to Chris? So when I say where first name equals Christopher, that's going to exclude everything, won't it? But let's see. So I'm going to run it. What did I do wrong here? Sorry about that. Incorrect. What's going on? This query literally just ran. Did I change something? Maybe, I don't know. There you go. You see it says 0 rows affected. 0 rows affected. And every time I run it, it'll be 0. Why is it 0 all of a sudden? Because all of the Christophers have already been changed to Chris. So let's switch it around. Let's say we want to change all of the Chris's to Christopher again. So I want to change first name to Christopher, where first name is Chris. Will that work? Will that work? Now what will this do? How many rows will be affected this time, guys? How many rows will be affected? 21, exactly. So let's run it. Okay, why did it say 22? I'm a little, oh, okay, you know what? There was probably one extra Chris in the table. There was one person who had the first name Chris. Again, now it'll always be 21. You guys were correct hypothetically. We just didn't know about this one Chris that already existed in the table, okay? Okay, but now if I run Christopher to Chris again, now it'll be 22 again, okay? And now it'll always be 22 because now all of the Christophers are whatever we set them to, okay? They just happen to be that one person who already had the first name Chris. Hopefully you guys understand. Hopefully that's not too confusing. You can see now it's always 22. If I run the same query twice, it'll be 0, okay? And now it'll be 0, 0, 0. Cool. So there's 22 Christopher. There were 21 Christophers originally and 1 Chris. We changed all the Christophers to Chris's, so there were 22 Chris's. Then we changed all the Chris's to Christophers, and so there were 22. And now we can like switch them back and forth. So hopefully that makes sense. Sorry about that one extra. I didn't know that there was another extra Chris already, okay? So sorry about that. Hopefully that makes sense. Anyway, okay, so you can see this is a non-query. It doesn't return any response. It just tells us the number of rows that were affected. And that's all the non-query does. If you run a query with execute non-query, then it will just return the number of rows affected. Okay, so let's try that out. Let's run this command. Okay, hold on. We're going to run the reverse of this command. So we're going to change all of the Christophers to Chris. Okay, so Christopher. There we go. We're going to change all of the Christophers to Chris. So I'm going to take this command. I'm going to put it inside the command text over here, right there. And we are going to run execute non-query, which will be an integer, okay? And we're just going to print that out, okay? So let's do that. So I'm going to build the solution, and we're going to go ahead and run it. And you can see it's 22. You see it returns 22. And if I run this again, guys, what will it return if I run this again? Because it's running that same non-query. Exactly, it's going to return 0, and you see it returns 0. There we go. So now you know the 3 ways that we can execute queries from C#. Execute reader, that returns the whole response in a forward-only reader. Execute scalar, that returns just the first cell, and it's very good for counting. And execute non-query returns the number of rows the query affects, okay? And that includes like the changing of rows or the removing of rows. Like you can imagine if we deleted all the Christophers, it would say that we deleted 22 rows, okay? That's what non-query would say. Same as updating, basically. Cool. Now another thing to talk about. So XML files and also text files are part of what we might call flat files. So these are just like files that store permanent data, but there are other ones as well. So, I mean, let's just talk about these for a little while. It's not too difficult, I don't think. So, cool, yeah, let's discuss this. So you guys have noticed this word forward only before. I've discussed briefly the idea of a stream, okay, but now we're going to explain it in more detail. So there is a namespace called system.io, okay, so we've used system.xml, that's for working with XML. System.data.sql client, that's for setting up your app as a SQL client. And we can say like using system.io, system.io. Okay, there we go. What does system.io give us? So IO stands for input output. IO, input output, okay? So this provides ways for working with what we call streams and backing stores. Streams and backing stores. So you can imagine, I'll just set this up for you. So these words are probably new to you, but they're pretty easy to understand. So a stream is just like a stream of water, except in computers, we're talking about a stream of data, okay? So that is a stream that flows from one place to another place. So if we have, and a backing store is either the source or the destination of a stream. Okay, so you can see it's like this. We have a backing store, a stream flowing from that backing store to another backing store, okay? So source through the stream to the destination. So let me give you a few examples. We could have a stream that runs from a database to a file, okay? So the one backing store is the database, the other backing store is the file, and the stream runs from the database to the file, okay? We could also have a stream that runs from a file to the console. You've seen that today, okay? You've seen that already today. When we read this XML file, that was a file. Sorry, I need more water. So we had a file and it output to the console, right? It was way earlier in the console. Okay, too early. But yeah, that file output to the console, that was a stream. The console is also just, you can see it's just a text file basically, right? It's just a bunch of lines of text really. So this is also a backing store. The console counts as a backing store. I think we can clean it up. Yeah, CLS clears it. Okay. So we've got, so that's a stream. We could also read from anywhere to anywhere, right? Like console to a file, database to a console. We can set up streams between all of these places, okay? So that's all a stream is, really. Okay, and there are two that I just want to discuss briefly, and I'll show you one of them now. So we can read and write from text files with streams, and text files are very good for a specific kind of thing, right? So text files are very easy for a human to read and understand because it's just lines of text. It's almost like a Word document. You guys have seen text files before, I'm sure. And we can read and write to text files. The problem with text files is that they're not good for storing some types of information. For example, if you were storing images or music or videos, it wouldn't be good to store them in a text file, right? That would make no sense. If we were storing those things, we would store them in a binary file, what's called a binary file. So we would just store a bunch of zeros and ones, basically, lists of zeros and ones. So you can work with all of these. We won't spend too much time on them because they all work in exactly the same way. They're all just forward only, okay? So I'm gonna show you a stream writer. So what we're gonna do, we're gonna take that query that we were running earlier that fetched all of the first names and last names, and we're just gonna write it to the text file. So we're gonna set a stream, we're gonna set up a stream that goes from a database to a file, to a text file, okay? And you can just imagine if it was music, instead we would just write to a binary writer instead of a stream writer, okay? And it would work in the exact same way, okay? So these are all just streams: stream reader, stream writer, binary reader, binary writer, okay? You've already seen a reader before. You've seen two readers, an SQL data reader, which was the thing that we read the SQL response in previously, and also you've seen a XML reader, okay? Both of those are just readers. And the stream reader would work in the same way if you were reading a file, but stream writer is just, we're writing to the text file instead. Anyway, I think that's enough setup. Let's just jump in. So I'm going to get back to the place where we had our previous query running, the one that was fetching all of the, there we go. So this was the one that fetched all of the first names and last names. I'll just run it quickly to make sure that that's still working after all the undos. Okay. And you can see it fetches, did we, wait, okay, there we go. It's fetching all of the first names and last names. It's a little bit slow. Listen, it is a Saturday morning, so we can forgive it, right? It's, wow, it's very slow. It's taking very long to read these first names and last names. Okay, there we go. That's the end of the list. Cool. All right, so that read all of the first names and last names from the database. And yeah, so that's doing that. Now, instead of writing that to the console, like instead of putting it here, I'm just gonna put it in a text file. We'll create a text file here, like new text documents, and I'm just gonna call it people.txt, okay? And instead of writing to the console, we're just gonna write here. And you'll see it be very easy because it's basically the same thing. We've got a stream that runs from a database to the console. And all I'm going to do is I'm going to move that stream to instead write to the text file. Okay. And how we do that is with a stream writer. So you'll see that it's pretty easy. All I'm going to do is I'm going to open up a stream writer. I'm going to be like stream writer. Okay. One problem. We need to say using system.io. Okay, because all of the stream writers and binary writers and stream readers and binary readers are in the system.io. So I'm going to say stream writer. Okay, I'll call it writer equals new stream writer. Yeah, I guess we will do it that way. Stream writer. And I must just give it the name of a text file that I want to write to. Okay, our text file was called people.txt. People.txt. There we go, people.txt. Now, literally, there is one change that I have to make here, guys. Literally one change. All I'm going to do is instead of going console.writeLine, okay, I'm just going to say writer.writeLine. Okay, that's it. That's it. Okay, so you see I've set up that new stream to the text file people.txt. And now instead of writing to the console, I'm just writing to the text file. And I think that's actually all we have to do. So I'm just going to build that and I'm going to run it. Okay. You can see it doesn't print out here anymore. It's finished. It doesn't print out here anymore. But let's go open up our text file. Okay. And there they are. There's all of our first names. You can scroll to the bottom, click on this line. You can see for some reason there's some extra lines. That's a little bit weird. I'm not sure. Maybe it got some spaces in there or there were some extra people. I don't know why there isn't 19,972 lines. But maybe there was some interruptions, but you can see that it did somewhat work. Maybe there's actually a limit on the amount of lines you can hold in a text file. That seems pretty reasonable as well. Cool, but that's that, okay? So that read from our text file. Pretty good. All right, so cool. That's that for stream writers, actually, pretty easy. So you see, I just set up the stream and you can see that's quite cool, right? That you can just, it's as simple as that. Now it's running to now the stream flows to the console and now the stream flows to the text file. Okay, as simple as that. All right, let's see. So I guess it stopped like at the first crystal here, crystal, yeah, I think. It's a little bit weird. Oh, well, computers are temperamental sometimes, I suppose. Okay, maybe we deleted some stuff accidentally, I don't know. Cool. Okay, and now the last thing. So you can see that the thing that I was drawing your attention to, right? Like we could see it with a stream reader as well, I think. It should say it, maybe. No, because it's in a different namespace, but it is, the principle is still there. All of these reader objects are what we call forward only. They move one way through the file. Now that's okay in some cases, right? Like if I'm reading through a database response and I don't care, like the things I read later won't affect how I interpret the earlier things, for example. Like if I read something later, I don't have to change something that I read earlier. Then this forward only idea is fine because I never have to go back. However, there are cases where there are relations between your data, where reading one thing impacts how you interpret another thing, okay? Where basically, instead of just being forward only, you need to be able to jump anywhere you want in the data. And for that case, there's the special thing called a data set, okay? A C# data set. And a C# data set allows you to store all of this relational data, this complex relational data, in the computer's memory, okay? Actively in memory, so you can work with it immediately, okay? Now, it's inside the system.data namespace, so let me just import that quickly using system.data, okay? So this namespace just has a whole lot of things for working with the relational data. You can see SQL client was also inside system.data, okay? Cool. So data sets can store relational data in the computer's memory, and you'll see why that's so useful now. Like I'll give you a simple example why it's useful, but also you can just imagine that it's no longer forward only. You can jump through it however you want, okay? because that actual relational data is now in the computer's memory rather than just being a stream from one piece of storage to another place of storage, right? Like rather than just a stream from the database to the console or the database to the text file, it's now actually in the computer's memory. It's ready to be worked with in the memory. Okay. Cool. So there are two ways that we can work with the data set. The one way we don't really care about, you can like just say dataset.readXML and give it an XML file to read from, and it'll read the XML file into the data set. But we don't really care about that way. The one that you'll be asked about is what's called an SQL adapter. Okay. So let me just show you this, and then hopefully it'll make sense. So we're going to get rid of our stream writer over here quickly because we don't need that anymore. And we're going to do some work with this SQL adapter idea. Okay. By the way, okay, we won't really be doing the example that they have on page 171.2 of the PDF I sent on the group for chapter 6. We won't really be doing that one because it's a little bit strange, really, I think. But it'll be somewhat similar. Okay, we're going to read our database instead. Okay. So cool. Let's do that. So we just need two things. We need the data set itself, which is where the memory will be, where all of this data will be stored in memory. And then we need what's called an SQL adapter that will actually fill the data set. That SQL adapter will actually fill the data set. And the adapter works in a very similar way to the data reader. So let me just set this up. So we no longer need to store the command, because the command will actually, like we can change this to a string, basically string command text like that, because the adapter will set up its own command. You can give it a command that you want to run. It's more adaptive, basically. The adapter is more adaptive, okay? And now instead of saying SQL data reader, we'll actually say SQL data adapter, okay? SQL data adapter, like that, okay? And I'm going to call this adapter. I'll just call it our adapter, okay? Cool. And the adapter just needs two things, okay? It just needs two things, okay? So we'll create a new SQL adapter, and it'll actually tell us what it needs. That's what's nice about using Visual Studio for C#. And for any language, actually, it'll always tell you what it needs. Let me see, how can we get it? Come on, tell us. Initializes a new instance of an SQL adapter class. Let me see. It's not great that it's not telling us what it needs, but maybe after I stop typing, it'll tell us. Okay, let me change that to a lowercase c so this Visual Studio stops complaining. And then we can say, cool. So what it needs is command text, okay? There you go. Now it's telling us, okay? So you see it needs two things. It needs the command text, a select command. You see it says select command text. So we've got that, select star from AdventureWorks. And it needs the connection that it is working over. So we're using the same connection. We're using the connection that we set up here and that we explained earlier. And we're using the same command, select star from AdventureWorks.person.person. So we've got our command text and a connection. That's all the adapter needs. And what it's going to do is it's going to take that query and it's going to store it. And all the SQL adapter is needed for is it's used to just fill a, you can see if I mouse over SQL data adapter, it tells me what it's for. It says represents a set of data commands and a database connection. So you see it tells us there it needs commands and database connection that are used to fill the data set. Okay, so it's used to fill a data set. Okay, there we go. So that's all. That's all it's for. It's literally its only purpose is filling a data set. So now we need to create a data set. So I'm just going to create a data set. We'll call this data set people. Okay, this is the people data set. Data set people. I'll keep it lowercase because that's good standard. Data set people equals new data set. Okay. Data set. I don't know what's with my typing this morning. There we go. Data set people equals new data set. And the SQL adapter is going to fill this data set. Okay, it's just going to fill this data set. Now remember the structure of this command because this is like the main thing. So how we fill a data set, we say adapter dot fill. Okay, so the adapter is going to fill the data set with its data. We give it the data set that we want it to fill. which in our case is the people data set, and we tell it what table we want it to fill the data set with. We want to fill it with the person table, okay? So that's the name of the data set, and that's the name of the table. Notice that it's given as a string. The name of the table is given as a string, okay? And now our actual data set is filled and it's in memory. It's in the computer's memory and it's full, okay? And you'll see that now. So we can say, guys, what command do I use to iterate over a collection? Just to make sure that you're at the end. This is the last thing that we'll see probably. What do I use to iterate over a collection as some extra revision? What repetition structure? Remember, we know of 4 repetition structures. Which one will I use to iterate over a collection? Exactly, we're going to use for each. So we'll say for each, okay? Cool. Now, the data set holds the actual database. So we can be like for each table, which we'll call a data table, okay? For each data table in people, okay? People is our data set. So in people.tables, okay? So for each data table in the people data set dot tables, and you can see if I mouse over tables, you see it says gets the collection of tables contained in the data set. Tables will give us the collection of tables contained in the data set, okay, like that. And then we can, so that gives us all of the tables. As we know, tables have rows, right? So we can say for each data row, so for each row in table, so in each table. So remember, we get each table here, and we're getting all of the rows inside that table, okay? And you can see if I mouse over rows, it says gets the collection of rows that belongs to this table. So we're saying for each data table, so for each table in people.tables, and then we're saying for each row in table.rows. In our case, we only have one table, just the person table, but you can imagine if we had more. And now we can work with this row inside memory. So we can just be like console.writeLine, and let's just do the same thing we were doing earlier. We're going to print out the first name and surname, but now you'll see that there's something different. I can say row in position first name, okay, plus row in position last name. Where do I get this? Where did I get first name, last name? Well, you can see if I jump back to our SQL query over here and just go back to where we had the select statement quickly. Sorry about that. Okay, here we are. And I just run that query. Okay, you can see the name of this column is first name and the name of this column is last name. And I'm just using the name of the columns here. Okay, and now I can just build this and run it. And you can see it gives me all the first name and surnames. Okay, so the data set, it's actually representing the rows and the tables, and you can see it has the names of the columns. It's much more powerful, you can see, than the reader. Remember, with the reader, we had to figure out like what like if I counted through this as an array, 0, 1, 2, 3, 4, we had to like count it. And you can imagine if we said, if we only wanted the first name and the last name, right? Like let's say if we said select first name, last name, now it's just giving us the 2 columns, right? First name, last name. And you can see now this is totally different. Now it's 0 and 1 instead of 4 and 6, right? But if with this, with representing the entire data set in memory, it's the same. It doesn't matter if we're using just fetching the columns because it knows the name of the columns. It knows the names of these columns, okay? So like that's quite a powerful thing, that it's representing the entire database inside the computer's memory. It's storing the entire database in there. Now, why might this not be good? The main reason why it could not be good is because if the database is very large, you can imagine that storing it in the computer's memory could be impossible, right? Maybe storing the entire database in memory is impossible if it's too large. So that's when you would rather use a reader, because then it just reads line by line by line. It's much less memory intensive, okay? So that's a case where this might not be the ideal, but for like smallest and even very large sets. I mean, don't get me wrong, like your computer probably has like 4 or even 8 gigs of memory. So it will be able to store large amounts of data. Like it's unlikely that a single table or 2 tables is going to be more than 8 gigs unless it's holding a lot of images and videos. So usually this will work just fine, but that is one disadvantage, that it's all in the computer's memory, okay, which can be very, very difficult for the computer to manage, okay. But that's actually it, guys. That is the end of all of the MTA content. Now, before we go, I just want to say, so let me just check. I have the schedule on my phone. So next week's lecture, I think some of the other schools are probably going to be joining us. Sorry, substation blew in the storm last night. Power is still not on. Wow, that's unlucky, Damien. Anyway, so next weekend, some other students from other schools are going to be joining us because we're doing a revision session for the exams. The exams, I think you guys have a choice. I'm not sure. We'll get back to you on the group. You can write on either the 7th or the 8th of December, and there will be 2 revision sessions before then. There will be an in-person revision session on, sorry, I just need to find it. Let me just see. There will be an in-person revision session. Where is this group, Dan? An in-person revision session on virtual on the 1st of December at Crawford Sanson. I'm not sure. We will be recording that as well, so you can watch it online if you can't make it live. So we'll be recording that. That'll be like an in-person session with like whiteboards, and there'll be a couple of tutors gathered there to like just revise the content. And then also in our next lecture, which would have been on the 28th of November, we'll be doing a virtual revision session. Some of the other students might be joining in as well. And if you can't make that one, there will be another virtual revision session on the 2nd of December from 5 to 7. But don't worry, we'll post all, the dates and times might change a little bit, depending on like when students' exams end. So we'll let you guys know on the WhatsApp group, like the final dates and times, but there'll be 2 different options if you guys want to attend virtual sessions. And if you want a face-to-face session, or if you just want to watch the recording of the face-to-face session, there'll be one of those as well. And that'll be like a 3.5 hour, like very intensive revision session. And then the exams will probably be on either the 7th or the 8th of December from 2 to 3, okay? And we'll have 2 different venues, like whichever one is more convenient for you. But yeah, we'll communicate more details about all of that stuff on the WhatsApp group as well. Okay. But yeah, we'll know more by Monday. That's when everything should be finalized. But yeah, other than that, guys, thank you very much for coming. Good lecture. I had a Mentimeter quiz for us to do, but you know what? I'll save it for the revision session when there's like lots of students. Okay. Okay, but yeah, thanks, guys.
Thank you, Josh.
Yeah, thank you guys for coming. See you next weekend, or maybe at any of the other revision sessions. I'm not sure. Yeah, thank you, Chris. Cheers, guys. Enjoy the rest of your weekend, and yeah, see you next time, whenever that happens to be. Yeah, bye, Yusuf. Cheers. You too.